Today's class is on chemical bonding, higher secondary first year, and the small topic on this chapter is overlapping sigma and pi bonds, and I will apply the sigma and pi bond concept on solving out a lot of entrance exam as I have written here to get the answer. First of all, before starting the answering the question, let us first tell me a little regarding overlapping sigma and pi bond. What is sigma bond and what is pi bond? Sigma bond is orbital overlapping, head-on overlapping. Say this is s orbital spherical in nature and this is another s orbital. If these two s orbital overlaps, then the overlaps is called side head-on overlapping, and this head-on overlapping give rise to bond is called sigma bond. Am I right? So this is the probability of finding the electron. Again, sigma bond may also obtained by p orbital overlapping. Say it is p px, and if this to get overlapped, so we will get this is again head-on overlapping, and this is called sigma bond. So we can get sigma bond by SS overlapping, by PP overlapping, PX PX, or P and S overlapping. There are three possibilities of getting sigma bond, that is head-on overlapping is SS, PP, SP. Am I right? Now, what are the ways how we get pi bond? Pi bond is sidewise overlapping. So, how we got pi bond? Say it is only possible in case of p orbital. This is sidewise overlapping. Am I right? So, this is probability of finding electron. If the two p orbital get overlapped sidewise, that is called sidewise overlapping. At the electron density cloud forms above the internucleus distances. There are two electron cloud density above and below, and both this cloud of density give rise to pi bond. So sigma bond is stronger than pi bond because there is more extent in sigma bond, and in case of pi bond it is weak bond because there is less extent in sidewise overlapping, extent of bonding. So when the extent of overlapping is more, it is in sigma bond, it is seen the bond is strong, and when the extent of overlapping is less, it is called pi bond. This is very simple thing, nothing to critical analysis is required to solve out the question answer. Let us first explain. In ethine, all the exams I have prepared in this way. In ethine, number of pi and sigma bonds are. What is ethine? Ethine means acetylene. This is ethine. This is ethine, or its name is acetylene. Single bond is sigma. Single bond is sigma. And in triple bond, there is two pi bond and one sigma bond. Any one may be sigma, any two may be pi. It is not necessary the middle one is sigma, any one. So total sigma and pi bond, and in double bond, one is pi, other is sigma. In triple bond, two is pi, one is sigma. Am I right? So you count yourself, very simple question. 1, 2, 3, 3 sigma, 2 pi. Answer of the first question is 3 sigma, 2 pi. Now, bond in chlorine molecule is due to overlapping of this is chlorine, and it is molecule means Cl here. So what type of overlapping here is? A lots of options are there. I will give you direct the answer. Answer is 1s, twice s, twice. So naturally, the electronic configuration of chlorine is 17. Am I right? Electron is 17. So it is in P. So when it ends up in P twice, chlorine and chlorine, there is P and there is P. So overlapping is PP overlapping. Here the answer is bond in chlorine molecule is due to overlapping of PP overlapping. Last electron enters in P. In both the chlorine there is P. So PP overlapping. Next one, number and type of bonding in calcium carbide. It is a very famous example. If you do not know the formula of calcium carbide, you can't answer it. Sometimes in the exam, you are asked, what is the structure? Calcium carbide. The structure is this. Am I right? Sometimes it is asked, what is the number of the sigma and pi bond in between carbon and carbon, and sometimes it is asked in JEE neat, what is total number on sigma and carbon in calcium carbide, sometimes in between carbon and carbon. So if it is in carbon and carbon, so this is pi and this is pi and one is sigma, that is 1 sigma 2 pi. And if it is asked in total how many sigma and how many pi's are there, so 2 sigma will come out. This will be 3 sigma and twice pi. It is in total in the molecule and it is in between carbon in carbide. Simple, nothing to explain more in detail. Next question. C single bond, C double bond, C triple bond, strongest bond. Right? Very simple. One is C1, other is C double bond, other is C triple bond. In my last class, I told you it is sp3, it is sp2, and it is sp. Here the percentage of S character is 50%. Here percentage of S character is 33.2. Here percentage is, I have explained you. More the number of the S character, shorter is the bond. Shorter is the bond length, more stronger is the bond. So in ethyne, the bond length order is this. So it is the least bond length, it is the strongest bond. Am I right? Next, bond, it is very important, very often asked in entrance exam. Bond I have also written from probably from AIEEE. Bond dissociation energy of BF in BF3 is, BF bond in BF3 is 646 kilojoule per mole, and CF bond in CF3, CF bond and CF4 is 515 kilojoule. What is the reason, correct reason that BF bond in BF3 is more than CF bond in CF4? I'm to explain. BF3 is planar, trigonal planar. Am I right? So there is pi pi extensive overlapping causes shorter in bond length in BF3. BF bond in BF3 molecule. Now let me explain what is the reason. What is pi pi? P pi, P pi, P pi, P pi extensive overlapping. How it is possible? That is not possible because it is tetrahedral. Am I right? So you see, it's carbon is how much? Carbon is 6 and hydrogen is 9. In B and F, that configuration, if you draw the configuration, boron is 1s2, 2p1, and fluorine, no doubt it ends up in P. It is P block elements. So there is P pi extension. So how does it helps in extensive? So what's happened here? One fluorine P is completely filled and carbon P is back end, and there is overlap. Due to this, p pi overlapping, due to this, what's happened? We get this configuration. Same things may occur in between these two. So we may write also in between these two. So as a whole, what we get, that double bond is once here, once here, once here. That is, in totality, we get, this is very interesting, double bond is resonance stabilized partial double bond, not single, hence bond length is decrease. Double bond, single bond to double bond, partial double bond, shorter is the bond length, higher is the bond energy. But in case of CF2, no such things happens, hence CF bond in BF3 is more than CF bond in CF4. Now, all 4 sigma bonds in perchlorate. What is perchlorate? If you remove this, if you remove this hydrogen, this is perchlorate. Am I right? So this will be centered. And you are asked all 4 sigma bonds in perchlorate. There is pi and sigma, pi, sigma, pi, sigma, sigma. 4 sigma bond. What is all 4 sigma bonds in perchlorate ions are in what types of hybridized it is? It is sp2, sp2. If you count the hybridization of this one, oxygen, the shortest way is one sigma bond, 2 lone pair, one hand, 2 hand, and in totality this is one hand. So 1 hand, 2 hand, 3 hand. 3 hand means sp2, 2 and 1, 3. So all are sp2 hybridized. So ozone molecule consists of, what is ozone? This is this 2 sigma 1 pi. This is band shape. Next one, pp overlapping seen in HBr, HCl, H2Cl. So you see, this is s orbital, and here there is p, s, p, s, s, one orbital, one electron is s. But here chlorine, a bit earlier I have shown the electron configuration of chlorine ends up in p5. So both the chlorine are pp. So the answer is pp overlapping takes place in chlorine. Very simple. In nitrogen, number of pi and sigma bond. What is nitrogen molecule? The nitrogen molecule is this pi, pi, sigma, 2 pi and 1 sigma. Am I right? Very simple. Which one of the following has p pi d pi bonding? Graphite. It is very important question. P pi d pi bonding. Graphite. Graphite consists of all carbon, only in structure in structure it is the difference. One is tetrahedral, other is in layer shift, sp2. Am I right? So graphite and diamond all are consist of carbon only, so pp. Am I right? So dimethylamine and triethylamine. What is triethylamine? it is very important. Trisylamine, trisylamine. So here carbon is P, and when you talk about that silicon, along with this you will get very close d orbital, hence there is the possibility of p pi d pi, because silicon is 14, 1s twice s twice p thrice s, this is 10, this is 1s twice s twice p thrice s thrice p 4s thrice d, so d is very close. So very often this in this trisylamine the d orbital is taken part in hybridization. So d pi, p pi d pi hybridations occurs in. Next question, number of sigma and pi bond in SO2. Now what is the structure of SO2? So this is pi sigma lone pair. So here 2 pi 2 sigma 1 lone. The answer is 2 pi 2 sigma and 1 lone pair. Next question is p pi d pi bonding seen in. I will explain how d pi comes. One of the examples I will explain are in sulfuric anhydride. So you be patient with me. So in this one, so just you see atomic number is 6, 7 and this is 16. Answer this. So here, because D is very close, the question, the trick is D is very close. So naturally, if you think of the sigma and pi, you will pi sigma pi sigma pi sigma. So 3 pi and 3 sigma. But in the question it is a bit twisted. You are asked not p, not pi. It is asked as d p pi d pi. So in pi there are two types of bonding. In pi bonding there is two types of bonding. One type is p pi and other type is p pi d pi. So the trick here is, without explaining the fact, I will explain it in later on. Out of three, one is p pi and two left. Am I right? There are 3 pi, two left. Two are p pi d pi. So there are three types of bonding. 1, 2 sigma, 3 sigma, and 1 p pi out of 3 pi, 1 p pi and 2 p d pi. I will explain how to, just you keep it in your mind. Next one is phosphoric acid H4P2O7, number of sigma and pi. If you know the structure you can, otherwise you can't. How many phosphorus? P and P. And next are O, H, O, 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 O. How many? O is 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And 1 2 3 4, hydrogen 4. Am I right? So this is H4P2O7. So now next part you can yourself do. This is sigma, this is sigma, 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 pi, sigma, pi. You count yourself, you can very easily do this part. So the balance of P should be here 5, 2, 3, 4, 5. Just you keep it in your mind. Other you can do yourself. You keep the bond of P is equal to 5 like this. Next one is number of P pi D pi, again HCO3 HCO4. HCO3, so xenon is equal to 8 valence electron and it is 6, 6 3 ja 18 is equal to 26. How to find out bonding and lone pair? I told you in the earlier classes. The quotient is your 3 bond pair and remainder is 2 electron. 2 electron is 1 lone pair. So there is 3 bond pair, 1 lone pair. So Xe 1, 2, 3 and 1 lone pair is there. Am I right? And here XeO4, XeO4, again it is 8 and it is 6, valence electron 6, 6 4 ja 24 equal to 32 is equal to 8 is equal to 4. It is sp3. No valence electron is there. So its structure is Xc. No lone pair of electron. Am I right? So out of this you are asked P pi D pi how much in X3O4. Here there is pi pi pi. So in this you will get 3 bonds, 3, and here pi 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 4. Answer is 3 and 4. 3 and 4. Sulfuric anhydride types of bond. What is sulfuric anhydride? H2SO4 is sulfuric acid and anhydride means you lost water from it. So if you lost water from it, so it will be write in this way. Am I right? So if you lost water out of this, you are getting SO3. So this is sulfuric anhydride after losing water. If you know this one, then you draw the structure, you will find the number of so S is the central, 1 2 3. You see whether lone pairs are there. It is 6 6 plus 6 3 ja 18 24 8. There is no lone pair, no lone pair. So pi sigma pi sigma pi sigma means there is 3 pi and 3 sigma. Now you are asked types of bond. When it is type, then here I have told you if there are 3 pi, then 1 pi is p pi and 2 pi are p pi d pi. Am I right? If you ask how, I told you that I will explain. So in sulfur, S2, 2s2, 2, S is 2, and P is 4. P is 4. Here P is 4 means 1, 2, 3, 4. Now, this is the block arrangement of orbital electron in ground state of S. Ground state. So, when they get hybridized, the atomic orbital of same atom get hybridized in hybridized concept, then S and P get hybridized. So, in this way, what's happened? One electron jumps to this one, and from thrice P jumps to this one. You see how de-utilized in pi orbital, in pi hybridization, pi bonding, the d orbital is taking part. So, what you are getting is sp. So, here sp, you take the 2 sp2 hybridized. So, this 1s and 2p, how much? 1s and 2p. 1s 2p means you are getting 3 block, 1 2 3. So here one is going jump to this one, 1 electron. Here one has jumped to this one, here remain 1 electron, and I have taken 1 here. This is so 1s and 2p is there, 1 3p remains. Am I right? In 3p there is 1 block left. In 3p there is single electron, and the jumped electron in the excited state, now it goes in this way, 3d. Am I right? So the interesting fact is that SO3, am I right? In SO3, so here in single and single and single, that forms 3 sigma bond, 3 sigma bond, and left pi bond, there are 3 pi bond. Am I right? So I have effaced out 3 pi bond. One is with 3p, it is 3p, so one is p pi, and among p there are 2 left. So these 2 will be, one from p, other is from d. So p pi d phi, and another is p pi d pi. So that is how in the p orbital overlapping, pi overlapping, so we get one is p pi, other is p pi d pi. The condition is that the p d orbital should be very close to p, otherwise it's not possible. So that one is for you, you can do yourself. See, this is pH, CH double bond, CCH3, single bond C2H5. You are asked to draw, find out number of sigma and pi electron. So pH means benzene. You draw the structure of benzene. So the fact is that just you draw the benzene structure, and here carbon hydrogen, and you make it split in this way, and CH3 CH2, you write it CH2 CH3. Am I right? So you are getting, this is sigma 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 sigma, pi pi pi, sigma sigma pi sigma sigma, all are sigma. You just calculate, it is a normal calculation, you will find out number of sigma. In 2002, there was a question, how much number of pi electron, pi and sigma and lone pair in pyridine. So those who know the structure, they can draw the structure of pyridine in this way, but in the book the lone pair is not given. Am I right? So maximum of them give sigma 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 sigma, pi pi pi. So 6 sigma 3 pi, but they gave lone pair is 0. So you should know the structure at all, first of all, otherwise you can't do the. Sometimes it may be given anthracene, may be given naphthalene. So 2 benzene fused, 3 benzene fused. You know the structure of benzene, then you break the benzene and you will find the sigma and pi bond. So Lewis acidity of BF3 is less than to BlCl3. BF3 acidity is less. Acidity less than BCl3. The fluorine is more electronegative. More electronegative. The answer already I have explained earlier. So in BF3, I told you that the electrons are in planar structure. Electrons are delocalized, and bonds, the bonds are localized in such a way that it becomes more or less in stable form due to resonance. So what is acidity means, Lewis acid, the species which very easily are able to donate the lone pair of electrons are called base, and the species which can accept the lone pair of electrons are called acid. So electron deficient species are Lewis acid, and electron excess species are Lewis base. Those can donate lone pair of electrons are called Lewis base, and those can accept lone pair of electrons are called acid. So that molecule should accept electron, but due to its stability due to resonance, it is no longer uh, uh, wants to accept this electron, but no such stability is seen here. So it will very easily accept the layer pair of the electron in it, because it is electron deficient. Am I right? So when the species is electron deficient, they very easily want to take up electron pair to make it octet. Then hence it is acidic. 1 2 3 4 5 6, 2 electron less, so it wants to take up 2 electron to cover up its octet, hence it is Lewis acid. So likewise it should also take the 2 lone pair of electron, but due to the fact I have already mentioned, it is stable resonance, and hence it is weak acid. O2, it is a linear structure, and you are asked to draw sigma and pi electron. You draw, you can very easily. This is tricarbon dioxide or carbon subdioxide, you can name it. So you yourself do it. You can count it yourself. Thanks a lot for watching the class. Please don't forget to subscribe, and also you will find next class, which is molecular orbital theory, and that class will be the last class on bonding.